So there's, your body expects this balance, and this is true in your eyes. It's true in your brain. One of the most interesting things that when I fixed my diet and when the people I was working with started fixing their diets based on my experience, is we all noticed that our vision got a bit sharper, right? And it typically happened pretty quickly. And I thought that was pretty interesting. I didn't really understand why until recently. But as you're taking up more omega-3 fats, the omega-3 fats are more active, in your cell membranes, and they can react better to light signals, and they're transmitting those signals onto your brain more effectively, right? So it's literally having an effect, that kind of a fundamental effect in your body where it can affect nerve transmission, your vision, it'll affect your immune function, because when your body has a immune response, it's going to take these polyunsaturated fats that are stored in the cell membranes and convert them into various different signaling molecules. And the omega-6 signaling molecules tend to be pro-inflammatory. They're telling your body to start an inflammatory reaction. And the omega-3 fats tend to be, don't want to say anti-inflammatory, but sort of resolution of inflammation signals. So your body needs both things there, both components, to do this signaling. And, if you get into a modern American diet where most people are eating a tiny fraction of the omega-3 fats that their body is expecting, well, they're really good at starting inflammation, but they're not going to be able to shut it down because they don't have the building blocks that they need to make these signals to calm down the inflammation in the body. So on both sides, there's kind of a hierarchy. The fats we can get from plants. On the omega-6 side, that's linoleic acid, basically. On the omega-3 side, that's alpha-linolenic acid. When those go into a higher organism, then they can be converted into what we call long-chain polyunsaturated fats, which are the EPA and DHA that we hear about. And on the omega-3 side, on the omega-6 side, it's primarily a fat called arachidonic acid. The long-chain fatty acids we get from eating animal foods. Okay. Plant foods don't contain those. Your body can make those from plant foods to an extent with, again, all sorts of caveats in there. Certain of these fats, if your body can't typically make enough of the omega-3 fats. So if you're on a vegan diet, you're not going to be eating any animal foods. You're not going to have a dietary source of these omega-3 fats, these long-chain omega-3 fats that your body needs. So you're going to be deficient in them, right? Which can cause neurological issues, vision issues. Typically, we would be getting some small amount of the short-chain fatty acids and then long-chain fatty acids on both sides from our diet. But as the American diet has been changed to reduce the amount of animal fat that we're consuming, we're getting most of these fats from plant-based sources. And for instance, with DHA, your body is really, really, really bad at making DHA from plant-based sources. In some studies I've seen in humans, they're unable to make any at all, right? And part of the reason for that is, the primary reason for that is that when your body is trying to make the longer chain fats that it actually needs from the shorter chain fats that it's getting in the diet, they're using a single pathway to do that conversion. And the omega-6 tends to block the pathway. So it takes up the pathway. So you wind up making excess amounts of the omega-6 fat, arachidonic acid, and you can't make enough of the omega-3 fats. So, that gets back to what I was describing before, where you wind up with a over allotment of omega-6 fats in your membranes and an under allotment of omega-3 fats in your membranes. Arachidonic acid is essential, right? And what that means in dietary terms is required for life and your body can't make it. So there are other things like, say, glucose is required for life, but your body can make all the glucose it needs. You don't need to eat glucose, right? An essential component of the diet is something that's required for life that your body can't make. So arachidonic acid is essential. DHA is essential. EPA is essential. three fats, one omega-6 fat, two omega-3 fats. Arachidonic acid is a super important fat because it's used to stimulate inflammatory reactions. So if you have an infection, if you get injured, it's used in developing your brain. So if you're deficient in arachidonic acid when you're developing, you're going to have serious neurological defects, right? So it's a very important thing, but you only need a tiny little amount of it. And it is very dangerous in the body. When it gets oxidized, it is extremely toxic, which is why your body is keeping it around as a signaling molecule. Because of that, your body tends not to, it makes more arachidonic acid when it has a need for arachidonic acid. It doesn't just automatically make it, right? I mean, this is kind of a straw man argument that people often make when they're describing omega-6 fats. And they say, oh, well, if you eat, too much seed oils, your arachidonic acid doesn't go sky high. Well, yes, because your body isn't dumb for the most part. And it knows that this is a dangerous fat, but it needs it, but it only needs a little bit. So it's very carefully regulated in the body so that your body has enough of it. Now, what seems to happen is when you get inflammation and it starts getting converted, that process is driven by how much you have in membranes. So then you can get excess inflammation because you've got, your body is expecting X amount of arachidonic to be around and it's got more than it expects because you're saturated, your entire body is saturated with arachidonic acid because it has all the precursors that it could ever want to make arachidonic acid. And additionally, part of the way that the arachidonic acid in the body is regulated is because the body will use omega-3s first, and then it will use omega-6 second. In a natural diet, your body is going to have a lot of omega-3 in your tissues and, less omega-6 than what we have now. But because we don't have enough omega-3, we wind up with a lot more omega-6 in our membranes than what we're supposed to have.
These seed oils are providing us with too many omega-6 fats, linoleic acid, which is rancid and toxic, arachidonic acid, the body's better at making that as it needs it as a whole. Do we ever have to worry about dietary taking in too much arachidonic acid like we do through linoleic?
I suppose it's theoretically possible, but I've never heard of a case in humans. I mean, it's in meat, but there's not a lot in meat. And people who eat nothing but a carnivore diet seem to be fine. So, I suppose if we went and did the same thing that we've done with seed oils, which is where so say you went to beef and refined out the arachidonic acid and gave yourself an enormous amount of that, would that be a problem? Yeah, it could be a problem, but nobody actually does that. So path 2, if the fat is not going to get used for fuel, it's going to be incorporated into your body tissues in a variety of different ways, right? Every single one of our cell membranes is comprised primarily of fats, right? And they are packaged together using a molecule called choline into a structure that creates the cell wall around every single cell. And those, they're called phospholipids, are typically a saturated fat and an unsaturated fat, right? Unlike a triglyceride, which has 3 fats attached to a glycerol backbone, a phospholipid has 2 fats attached to a choline backbone. And there's some other variations on that we won't get into, right? But your body very much likes to have saturated fat. I mean, it's kind of funny idea that we've been pursuing a low saturated fat diet for the last gosh knows how long. Your body makes all the saturated fat that it needs, right? It preferentially makes saturated fat because it needs it for every single molecule in every single cell membrane in your entire body, right? The first fat is always a saturated fat. And then the second fat is either a monosaturated fat or a polyunsaturated fat. So even if you don't eat any saturated fat at all, your body will make all the saturated fat it needs because it has to have a certain amount of it for your body to exist. Not eating saturated fat is kind of ridiculous, right? Same thing with monounsaturated fats. That's what your body prefers to use as the second fat. And If you don't eat any of it, then your body will just make it from the saturated fat. It'll make it saturated fat from the carbohydrates and then monounsaturated fats from the saturated fats. Your body can't make polyunsaturated fats, right? And your body has to have a certain amount of polyunsaturated fats for it to function correctly, for your cell membranes to function correct. Because one of the things that your cell membranes do is pump things in and out of the cell, okay? And these chemical pumps that your body uses actually depend on the molecular energy of the fats that comprise the membrane to work, okay? So if you take one of these pumps from an animal that has, say, a lot of polyunsaturated fat and put it into the cell membrane from an animal that has less polyunsaturated fat, it will run slower. But at any rate, so those are the two pathways, fuel or structure. And the type of fat is very important for the structure. In things like your eyes or your brain, your body needs a certain amount of polyunsaturated fat in order to function correctly. Two types of polyunsaturated fats, that we're going to talk about, omega-6 and omega-3. And omega-6 fats generally come from seeds in the environment. Omega-3 fats generally come from leaves in the environment. Make that distinction because mammals can't make polyunsaturated fats, right? We have to eat them. So you and I get them by eating something else that either ate a leaf or a seed or ate something else that ate a leaf or a seed. At somewhere down the chain, there was a leaf or a seed that produces these fats, right? There's a plant that produced these fats for us to eat. Say we eat a cow, right? Cows, in the normal course of things, mostly eat grass, leaves, and they're going to get a lot of omega-3 fats. So your body has evolved to expect this balance in the environment of roughly 1-to-1 or maybe 2-to-1 of omega-6 fats to omega-3 fats, right? But roughly a balance. So the fats have a variety of different purposes in the body. They're part of our immune system. They're used for signaling. So for instance, when you get hungry, you are experiencing hunger because your body is taking omega-6 fats out of the gut line, out of the lining of your intestines, and turning them into basically a drug called an endocannabinoid that goes to your brain and says, I'm hungry. Now, there's supposed to be a balance there, and it's supposed to be, the omega-3 fats don't have that hunger-causing effect. So if you have lots of omega-6 and not enough omega-3, then all you're going to get is the hunger signal constantly, right? Too much of a hunger signal, and that will cause you to overeat. They're very susceptible to going rancid, right? And rancidity isn't something that we hear a lot about nowadays, but it used to be a big concern. Rancid fats are toxic fats. You want to avoid eating things that are toxic. And seed oils are, of all the fats that we consume, the most likely to go rancid and become toxic. And the result of that toxicity is, I would argue, why we have this epidemic of chronic disease.
So when we talk about rancidity, making them toxic, where along the processing does that happen? So when does that happen throughout that process?
It happens throughout the entire process, right? I saw a really interesting talk, and the guy compared seed oils to LDL, right? Seed oils are 400 times, contain 400 times as many rancid fat molecules as an LDL particle does, right? Now, an LDL particle, we all hear lots about LDL, but most of us don't understand that a native LDL particle is totally harmless, right? So that's a pretty good thing to use as your benchmark. And if you are consuming vegetable oils, seed oils, that contain 400 times as many rancid fat molecules as an LDL, those rancid fat molecules are going to go into the LDL, and they're going to become atherogenic LDL, right? That's what your cardiologist is worried about. He's worried about LDL particles with rancid seed oil molecules in them, basically. And this has been known since the 1980s. To be the primary driver behind cardiovascular disease. I would argue that all vegetable oils are rancid. They do have a standard for rancidity. I haven't been able to find yet why they have that particular standard, but that standard is 400 times what your body is expecting. So that's a problem. Okay. They also are, so you consume rancid oils, your body absorbs the rancid oils, absorbs them into things called chylomicrons, which are basically delivery packages. It's a type of lipoprotein similar to an LDL particle. And it shunts these into your bloodstream. And the first place that they go is to your heart, right? Your heart loves fat for fuel. So when you eat fat, your heart gets first dibs on the fat. So if you're eating rancid, toxic fats, obviously having that bolus go straight into your heart first place is not exactly ideal. And then from there, after your heart and your arteries have a chance to absorb it, then it goes out into the rest of your body and gets absorbed. And, at a later date, your liver gets the opportunity to detoxify it and then send it back out into the body in LDL particles, or in VLDL, which are turned into LDL particles. I think one of the most surprising papers that I found in looking into this stuff was a paper from the 1950s when they were trying to determine why you get radiation poisoning. Good question, right? And it turns out that you get radiation poisoning because the polyunsaturated fats in your body get oxidized and they're toxic, right? So radiation poisoning is effectively polyunsaturated fat poisoning. And they took these rodents and they injected, so the primary fat molecule in seed oils is a fat called linoleic acid. They injected rancid linoleic acid hydroperoxide, into these rodents, and it killed them very effectively. Since the 1950s, it's been understood exactly how toxic these are. In fact, they've used it as, I saw another paper that made me very mad when I first saw it, and after a while I realized it made a lot of sense. They were talking about using vegetable oils as a cancer treatment, right? So they would feed someone, the theory was, and they did this in animals, that they would feed you a lot of vegetable oil, and then they would use radiation to oxidize the vegetable oil in the tumor, and that would kill off the tumor. And what kind of effect does it have on your body? I mean, we know this in great detail, right? A rancid fat can cause another fat to go rancid, so it can cause a chain reaction in your body. This is why we have antioxidants in your body, right? The primary antioxidant in the body is something called glutathione. And if you, for instance, have an animal that can't make glutathione, it won't be born because the lipid peroxidation, is the term for rancidity, is if you don't have a way to break the chain reaction, it will kill you quite quickly, right? So if you are unable to make glutathione, you're not going to be born because you will die in the uterus. So it can cause other fats to become rancid. The rancid fats can go and damage proteins. It can damage DNA. Pretty much any other molecule in the vicinity is going to be susceptible to the effects of these toxic rancid fats. So, for instance, one of the more gee whiz, that's terrible things I saw is there's a paper talking about how people can become allergic to their own DNA, right? That's horrible. And they're not really becoming allergic to DNA. It's that these rancid fats are binding to DNA, and the body sees these rancid fats essentially as indicative of a bacterial infection. And so just like with poison ivy, which is also caused by rancid polyunsaturated fats, right? The poison ivy rash is the same process. Your body interprets this as an infection and goes to try and clear out the infection. Now, of course, it's not an infection. There's no bacteria or virus there. It's attacking your own body. In that case, the DNA. Obviously, being allergic to your own DNA is a very bad thing. When you eat a fat, I don't know what the exact, well, let's just say there are two paths that this fat molecule is going to take, right? One of them is going to be used as fuel and be oxidized. and polyunsaturated fats are preferentially used as fuel. They think that happens essentially for the same reason that your body has like a cascade of things that it will use for fuel, right? So at the top are things like ethanol, right? Ethanol is toxic. Sorry, guys, but it's just true, right? So when your body gets ethanol, it wants to get rid of it as quickly as possible. And one of the ways that it does it is by oxidizing it, using it for fuel. Glucose, same thing. When your body eats glucose, it ramps up its metabolism, because one of the ways it gets rid of excess glucose, which can also be toxic, is by using it for fuel. So fats are the same thing. In fats, there's a hierarchy, right? The polyunsaturated fats are the most unstable and therefore the most likely to become toxic. And they are the ones that are preferentially used for fuel. And they're used basically in order of the likelihood that they're going to become toxic to the body. Next step down, monounsaturated fats, like the fats in olive oil, those can become rancid, but when they do, they don't become very toxic. And, that's one of your body's favorite fats is monounsaturated fats, because it can use them, for phase 2 that we'll get to in a minute. And then the most stable ones, the least likely to become rancid, are saturated fats, right? So when your body gets excess glucose, the first thing it does with it is use it for fuel. Second thing it does with it is turn it into a saturated fat, because that's the safest storage form that your body has.